Hello everyone. So welcome to the second class of PCCCS 303, that is Computer Organization and Architecture Theory. So in this class our objective is to clarify the doubts regarding the registers and clarifying the doubts between the memory locations, and we also try to give some concept of arithmetic operators or arithmetic expression evolution. We also try to clear the doubts regarding uh, the how to execute a program in assembly level language with the help of 0 address, 1 address, 2 address and 3 address instruction. Okay, if I am properly audible and properly visible, then write it down the YouTube chat. Your chat box is now active. Please write it down in the YouTube chat if I am properly audible or visible. I am waiting for your response. After you respond, I shall start my class. So I am waiting for your reply in the chat box. So your YouTube live chat is active now. So after your response, I will continue my class. Thank you. Thank you for your reply. That means I am audible and properly my screen is properly visible, and I hope that there is no buffering problem, there is no echoing problem. I have made the YouTube chat alive so that you can able to, your response can able to come to me directly. But if any kind of unavoidable circumstances occur during my lecture, or if you make some comments which are not appropriate, then I will close the YouTube chat. Okay, then you need to reply it back with the help of my official WhatsApp number. But before writing any kind of WhatsApp messages, you must write your section name and roll number, then write down your comments. I repeat, if any unavoidable circumstances occurs, such as by making some unexpected or unprecedented comments, then I will stop the YouTube chat box, and then you need to communicate with me via WhatsApp messages. And before writing any message, you must type your section name and roll number, then you should write your comments. Otherwise I will not give the answer of your comments. First, our objective is to explain the classification of register. Normally registers are of 2 to 3 types. A, for accumulator registers, my WhatsApp number is 9434219068. My WhatsApp number is 9434219068. First of all, I would like to discuss about the different classification of registers. First register is A. A stands for accumulator. Accumulator is normally a 8-bit register if our system supports 8 bits or our CPU or processor is of 8-bit. Accumulator may be a 16-bit register if my processor or CPU supports 16-bit. Accumulator may be a 32-bit, 64-bit or 128-bit register if my CPU or microprocessor supports 16, 32 or 64 or 128 bits. What is the purpose of accumulator? Accumulator is helping us to perform the addition, subtraction, multiplication, division, increment, decrement and data transfer operation. I repeat, accumulator is helping us to perform different types of arithmetic operations. It also helps us to perform different types of logical operation such as AND, OR, NOT, OR, etc. Okay. Next, before the any kind of operation, one of the operands may be stored in accumulator. For example, during whenever I am writing multi x, so in multi stands for multiplication and x is a memory location or memory address. So you can think that x is basically holding a data before the multiplication. Where is the other data located? Other data is automatically located in the accumulator or ACC or AC or A. So whenever I am writing multi x, then what happens? Accumulated data and the data of x memory location are multiplied. Where the result is going to be stored? Result is going to be stored in a accumulator or a register or ACC or AC. Our next category of register is GPR. GPR stands for General Purpose Register. G for General, P for Purpose, R for Register. We have normally observed that there are 6 General Purpose Register in normal computer or normal CPU or normal processor or microprocessor. First is B register. B register stands for base register. Base register of any array, string or any memory location may be stored in this register. That's why it is known as base register. B register sometimes act as a data register also. So whenever we need to perform any arithmetic, logical or shifting or data transfer operation, we may require B register. Next is C register. C register is known as counter register. Often whenever we want to perform any operation with the help of loop, suppose for loop, while loop, do while, etc., we require the C register. How many times the loop will iterate, that number may be stored in C register. I repeat, C register is used for loop. How many times the number will be how many number of times loop will be repeated, that will be stored in the C register. That's why C is known as counter register. Along with C register, BC register makes a pair where the base address of any array, string or any memory location can be stored. Any contiguous memory location can be stored. I repeat, along with C, B and C makes a pair register, BC register pair. It is known as BC register pair, and they are capable of storing an memory address, and that address should be the starting address of any array, string, etc. Next is D register. D register is data register. It is capable of storing data before the arithmetic, logical, shifting or data transfer operation. And similarly, E register is also a data register. Before the operation, E register is holding the data, and E register is may store the data after the result is generated. Next is HL register. H is higher order address register, L is lower order address register. Suppose 9050 is an hexadecimal address. Suppose 9050 is an hexadecimal address. So 90 is the higher order address, 50 is the lower order address. How to determine which part is higher order, which part is lower order? Very simple. 9050, you should divide it in between. So if I divide 9050 in between, one part is 90, another part is 50. So 90 will be higher order and 50 will be lower order. Higher order address 90 will be stored in H register, and lower order address 50 will be stored in L register. So H and L register together, they are known as address register. H and L together, they are known as address register. H and L together, they are known as address register, and they are used to store the address of any memory location such as 9050. H and L are also known as register pair. H and L combined together, they are known as register pair. Our third category of register is SPR. SPR stands for S for special, P for purpose, R for register. S for special, P for purpose, R for register. Our special purpose registers are mainly three. There may be lots of special purpose register, but mainly three types of special purpose register. Am I audible and properly visible? Is my screen is properly visible to you all? Am I audible to all of you? Please reply it via YouTube chat. So SP is basically the stack pointer. Stack pointer I showed you earlier regarding the stack related operation, that SP is basically the stack pointer. Example. Suppose 23 data is stored and then minus 21 data is stored. The bottommost address of the stack is suppose 752 and topmost address of the stack is 751. So stack pointer will store 751 address. So let us make it 7510. Let us make it this way. Suppose bottommost address is 7511. This is 7511 and previous address is non-naturally 7510. So stack pointer is normally, this is the topmost element of the stack, which is 23. Now stack pointer is pointing the topmost element's address. Our topmost element is 23. So 7510 is the address of it. So stack pointer holds this address. Stack pointer holds this address. This address. So this is the operation of the stack pointer. Stack pointer normally points the topmost element of the stack. Stack pointer holds the normally topmost element of the stack. Next is program counter. Program counter is basically holding the next instruction address to be executed. The next instruction address, the next instruction which to be executed, its address is stored in stack pointer. For example, say LDA 9050. For example, say LDA 9050. So let us assume the starting address of this instruction is 8000. What is the, now suppose LDA 9050 is the current instruction which is executing by the CPU. Suppose LDA 9050 is the instruction which is currently executing by the processor. Now which is the next instruction to be executed? At A comma B. What is the address of it? 8003. So the value of the program counter will be 8003. Value of the program counter will be 8003. Value of the program counter will be 8003. What is IR? Instruction register. It holds the opcode of the instruction. Currently which instruction is executing? Currently LDA 9050 is executing. What is the opcode of LDA 9050? Let us assume the opcode of LDA instruction is 3A. So the value of instruction register is 3A, which is nothing but opcode of LDA, So instruction register or IR stores the opcode of the current instruction which is executing. Currently LDA instruction is executing and its opcode is 3A. That's why we have stored 3A in IR registers. Next, when I treat register, sometimes it totally, when I sometimes I treat A, B, C, D, H, L these as general purpose register or accumulator or whatever, and sometimes I treat A, B, C as memory location. It totally depends upon the programmer how they are assuming it. For example, C is equal to arrow means is equal to, C is equal to A plus B means I am adding the value of A and B and storing the result to C. In this example, A is a memory location, B is a memory location. I am adding the value of both and storing the result to C. So look at that, M of A, that means the value of A memory location, and M of B, that means the value of memory location B will be added together. Say this is 2, this is 3, so 2 plus 3 is 5, then I stored it in C. Again I am repeating, when A, B, C, D, etc. these are treated as register or these are treated as memory location, this is totally upon the programmer, totally upon the designer. Okay, now I am basically coming to arithmetic expression, how arithmetic expression are evaluated by, basically evaluated by stack. We know that a stack is supporting 3 types of notation. First is infix notation, for example A plus B within bracket, that can be a notation, not bracket. Let me delete the bracket so that we cannot get confused. A plus B, so this is a infix notation. What is the speciality about the infix notation? In infix notation, operator is in between 2 operand or operand location. Here plus is an operator, it is between A operand location and B operand location, hence it is an infix location. Next is polish notation. Next, type 2 is polish notation. Polish notation is sometimes known as prefix notation. What do you mean by that? First operator, then operand. So A plus B, so operator if goes first, then plus will come first, then the first operand location, that is A, then the second operand location, that is B. So first operator, then operand location. As because plus is a binary operator, it requires 2 operand location. One location is A, which stores the data value say 2, another location is B, which stores the data value say 3. Our next types of notation is postfix notation or reverse polish notation. Please try to understand, stack is mostly operated in reverse polish notation. For example, the reverse polish notation of A plus B infixed will be AB plus. Am I properly audible and visible? Am I properly audible and visible? Please write it down in the chat if I am properly audible and visible. Please ask your question if you have any kind of questions. Please ask it in the chat box, YouTube like chat box. Okay. Please ask it in the YouTube like chat box if you have any kind of doubts. Okay, then I am audible. So in our stack is basically operated in reverse polish notation basically, or postfix notation. So first of all, if an infix notation is given, our first objective is to convert it into a reverse polish notation or postfix notation. What is that? First we need to at the right hand side, at the rightmost side, we need to place the operator. Here plus is the only operator in this expression, so I placed it at the rightmost side. Then our 2 operands from left hand side. First operand is A, which is stored in the left hand side. Second operand is B, which is stored after A. Then we store plus. So suppose A minus B into C within third bracket, C divided by D plus E plus F. This is an infix notation. How we can able to convert it into a reverse polish notation? We are only concerned here with because of to perform arithmetic operations or evolution using stack, we are only concerned about reverse polish notation because it supports postfix notation. Stack only supports postfix notation. So how to perform that? First of all, the a b minus, so that is the reverse polish notation of AB. As because bracket is there, brackets has the higher priority than minus or plus or multiplication or division, whatever. Then we need to perform the bracket operation in of this, that means D and E, this operation to be performed, that is DE plus, we have written that. Then we perform the divide operation because plus and between plus and divide has the higher priority than plus. You can observe it from this table. First exponential, then multiplication, then divide, then plus, then minus. First bracket works should be done, then second bracket, then third bracket. Okay, so now what to do? Then we see perform the operation in between these two. So DE plus, so D plus, we perform the divide operation between those. So D plus is my first operand, C is my second operand, and divide is my operator here. So I write it down here. Now what happens? This becomes our next first operand and F becomes our second operand. So first operand, then second operand, then plus. Now what happens? We perform this. Now this becomes my second operand, and this AB minus becomes my first operand, and we perform the multiplication between these two. So now this becomes the reverse polish notation of this infix notation. Now let me explain how reverse polish notation can be evaluated and how resultant value can be generated by the system. To explain this example, I have taken an example, say 2 plus 4 into 4 plus 6. So this is written in infix notation. So how to represent it by postfix notation? 2 4 plus, 4 6 plus, and then multiplication. Okay, because the first bracket operation to be performed first, I can choose any of the operation, either 2 plus 4 first, then 4 plus 6. If I choose 2 plus 4, then the postfix upon notation will be 2 4 plus, and if I perform 4 plus 6 after that, then it will become 4 6 plus. If I perform the multiplication between two first operand and second operand, then it will be 2 4 plus, 4 6 plus into. So what I need to do? What is now? I need to scan the data from left hand side to right hand side with operand or data with operators. First I visit 2. So I pushed 2 in my stack. Now my stack pointer is pointing the address of 2. Next I scan 4. So now my stack pointer is pointing the address of 4. Next I scan plus. So what happens when I scan plus? Then what happens? Automatically 4 will be popped from the stack, 2 will be popped from the stack. An addition or plus operation will be performed between them. So 2 plus 4, that becomes 6. So I pushed it into the stack. Again I am saying, whenever I scan plus or an operator, then what happens? First element of the top stack is popped, which is 4. Then second element of the stack will be popped. Okay, because the plus operator is a binary operator. Then we perform the addition between 4 and 2. What is the result? 6. Now we push the result in the stack. Now stack pointer is pointing the address of 6. Next I scan 4, so I pushed it over 6. Next I scan 6, so I pushed it over 4. Then I scan plus. Plus means I need to pop top 2 element of the stack. Top 2 elements and 6 and 4. So I pop 6, then I pop 4. Okay, after that I perform the addition operation between 6 and 4. 6 plus 4 is equal to 10. I pushed it into the stack. Now stack pointer is pointing the address of 10. Then I scan multiplication operator. That means first two elements of the stack to be popped. First 10 will be popped, then 6 will be popped, then I perform multiplication between these two, so now it becomes 60. So now 60 is the result. So if any infix expression is given, my stack is capable of performing the operation which is known as postfix evolution. So first of all, if any infix expression is given, that to be converted to a postfix notation, then it should be evaluated in the following way, and then we generate the result, which this total functionality is known as postfix evolution. This total functionality is known as postfix evolution. Next, we try to explain the instruction length. Instruction can be of 4 types based on their lengths: 0 address instruction, 1 address instruction, 2 address instruction, and 3 address instruction. Okay, am I audible and properly visible? Please write it down in the chat box if I am properly audible and visible. Am I audible and visible? Is my screen is visible? Am I audible to all of you? Okay, so first of all, I shall explain the 3 address instruction. 3 address instruction has 3 different fields. Look at that: add R1, A, B. 3 fields. After add, there are 3 fields: 1 for R1, 1 for A, 1 for B. Add R2, C, D. 1 for R2, 1 for C, 1 for D. Sub X, R1, R2. 1 for X, 1 for R1, 1 for R2. So 3 fields are there. So if any instruction supports 3 fields, after the instruction is written, add, sub, multi, div, etc., they load, store, etc., then I can say this instruction is a 3 address instruction. So what I need to do, I need to express this infix expression with the help of the 3 address instruction. These instructions are written in assembly code. These instructions are written in assembly code. So first of all, I need to perform the operation within the first bracket, so A plus B. So what happens? A and B value here, please I to understand, A and B are not considered as register. They are considered as memory location. R1, R2 are considered as register. I repeat, here in this example, A and B are not considered as register. A and B are considered as memory location. R1 is considered as register. So what happens? The value stored at memory location A, value stored at memory location B are added, and result will be stored at R1. Okay, so next what we do, next we need to perform C plus D. So what will be our instruction? C is a memory location from where we are retrieving the data, and D is a memory location from where we are retrieving the data. We perform add operation because there is an add instruction written there, and then the result will be stored at R2 because R2 is the third field. Third field denote the destination field where the result will be stored. Second field will be a field where the first data will be stored. Third field will be a field where the second data before the operation is stored. Next, next what I need to do, I need to perform between A plus B and C plus D. A plus B is now stored at R1. C plus D is stored at R2. Now what I can do, I can perform sub X R1, R2. That means the R1 which is storing the value of A plus B and R2 which is storing the value of C plus D. Now they are subtracted together, and the result or difference of the subtraction is moved to the memory address X. Okay, so this is 3 address instruction. In this way, I can perform 2 address instruction. What is 2 address instruction? 2 address instruction has 2 fields after the instruction. So add A, B. It is a 2 address instruction because add is an instruction. After the instruction, there are 2 fields A and B. So let us look into the fact how this infix expression x is equal to a plus b minus c plus d will be evaluated by two address instruction. So first of all, what I do, load r1 comma a. So the value of a register, or sorry, value of a memory address will be loaded to r1 register. Now add r1 comma b. What does it mean? That means the value of b memory location will be added with r1 data, which is basically the memory address data of memory address a will be added, and result will be stored in r1. So a plus b is done. Now we need to perform c plus d in the same way. So I cannot use r1 because a plus b has to be stored somewhere. So I use r1 to store a plus b. Next is load r2 comma c. So c value will be loaded to r2 register. Please try to understand here, c is not a register. C is assumed as a memory location. So the value of the memory location c will be transferred to r2. Then add r2 comma d. What does it mean? The value of r2 register, which is nothing but the value of c memory location, will be added with the value stored at memory location d, and result will be stored at r2. Here r2 is denoting the first operand, and r2 is also used for storing the result. Next I need to perform a plus b and a minus c plus d. Where a plus b is stored in r1 register, where c plus d is stored in r2 register. Now we need to perform sub r1 comma r2. So r1 comma r2, if I do that, resultant value will be stored in r1. Sub r1 comma r2 means value of a plus b, which is stored in r1, value of c plus d, which is stored in r2, will be subtracted, result will be stored in r1. Next I need to transfer the result or sweep the result in x memory location. To save the data from a register, we used store instruction, whereas in opposite case we use load instruction. So ultimate data, that means a plus b minus c plus d is stored in r1. So we are moving that data to x. By store x comma r1, we are moving the result from r1 register to x. Next day I will continue 1 address and 0 address instruction. Thank you all for joining this lecture.